Hello everyone, and welcome to the lecture on linking plots. In this lecture we'll look at link panning and link brushing. They both are methods used for linking plots. If you go to the documentation here, you'll see the documentation for linking plots, and linking plots is used to connect two or more plots so that you have better interaction among your plots. Let's start by looking at linking plots by using link panning. So link panning, as you see here, it's used to pan or zoom actions across many plots. So here there is an example. So this is the effect. If you, let's say, move one of the plots, you see all of the plots are moving. Okay, if you zoom in into a certain section, you'll zoom in all the plots. So any action that you perform here in one of your figures, it's also linked to the other figures. So that's what link panning is. Let's see an example of that. So we'll start by importing output notebook and show from bokeh.io, and from bokeh.plotting we'll import figure, and from bokeh.layout let's import grid plot. We saw grid plot in the previous lecture. That's how we'll be linking them and presenting each of our figures as a grid plot. Okay, let me run this, and we have our output notebook function here, and we'll use the same x and y coordinates that we used in the previous lecture. You can use this x and y values, or you can use any values that you like. Great. Let's start by creating a new figure, and then we'll save this in a variable called p1. So that will be equal to figure, and then let's pass the plot width and plot height attributes. So plot width, I'll pass 255, and then for plot height I'll pass 250. So those attributes fit my Jupyter notebook well, and the next thing we'll need to do is call the various markers on our p1 figure. So p1 dot, let's use circle as our first marker, and we'll pass our x and y values, which is x and y0. Let's pass the size attribute and set it to 13, and for color let's use green. Since it's a circle, we can also pass the fill color attribute and set it to be yellow. So that's our first figure. Now let's move on to our second figure for our grid plot, and we'll save our figure object in a variable called p2. So we have our figure, and then let me simply copy this to save some time, paste it here, and change this to p2. We have our plot width and plot height. Let me copy this also, paste it here, and change it to p2. And for our second figure, let's use a diamond marker and pass our x value, and our y coordinate will be y1, size 13. Let's use a different color, red, and fill color we can use orange, it doesn't matter. So this will be our second figure. So now there are two more things that we need to do or pass in this figure attribute, which will help us connect our first figure to the second figure. So we'll need to pass the x range and y range attributes. So by passing those attributes, we'll set them to be equal to the first figure's x and y range values. Okay, let's do that. So we have our figure, and then the first attribute is known as x underscore range, and we'll set that to be equal to our first figure that we'll call the same x range function. Okay, so you have x range of figure 2. We'll set it to be equal to your first figure's x range. So now the x values are linked. Similarly, to link the y values, we'll pass the y range attribute and we'll set it to be equal to our first figure's y range value. So it will be p1 dot y range. Okay, now the x values and the y values of our second figure are linked with their corresponding x and y values of figure 1. That's how we link them. Okay, now we can move on to our third figure. Let's start by creating our figure object and save it in a variable called p3. So we set it to be equal to figure, and we'll do the same thing. We'll use the x range and y range attributes and link the x and y values of our third figure to the x and y values of our first figure. So we'll say x range is equal to p1 dot x range, and then to link the y values, we'll pass the y range attribute and then set it to be equal to p1 dot y range, and we'll also pass our plot width and plot height attributes. 255 for plot height, we'll pass 250, and then we'll call our marker object, our marker method. We'll call the square method for our p3 figure, and then pass our x and y values, which will be x and y2. We have our size. We'll set it to be equal to 13, and let's pass the color attribute and set it to blue. And you can pass the optional alpha attribute and set it to 0.8. Let's add some alpha values to the other figures also. Let's make this 0.5. Okay, we'll leave the orange one as it is. Okay, now that we have defined our three figures, let's use the grid plot method and then pass the three figures so that we have our grid plot. And we'll save it in a variable called p, and that will be our grid plot. And we'll pass our three figures as a list, which is p1, p2, and p3. And finally, we can simply call the show method and pass our p object. Now, if we run this, we have our grid plots, and we see that whatever action we perform on one of the plots, one of the figures, will also be done to the other figures, right? Okay, we can reset it. Where is the reset button? Okay, there is one thing missing in our grid plot, which is, so here we have our x cubed graph, which is great, whereas for our x squared, the x squared graph doesn't look like this, does it? No, right? And our first graph is a little bit off. So if you go to the previous lecture, this is what each of the graphs look like, but the first and the second one don't look the same as this. That's because here in our p3 figure, we have linked both the x and y ranges, but we don't necessarily need to do that. So for this third figure, we only need to share one of the range, which is the X range. So let's do that. Let me copy this and paste it here. Okay, so we don't need to share and set both of the X and Y range. So for our figure 3, we'll only need to set the X range and then set it to be equal to your first figure's X range. Okay, now let's run this. Okay, much better, right? Here we have your first figure, the second figure, which is X squared, and your third figure. So you can do the same thing. Whatever action you perform on one of your figures will also be performed on your other figure. And by default, you have all of your tools here. Okay. If you don't want to see any of the tools here, you can pass the toolbar attribute and set it to be equal to none. We saw that in the previous lecture, right? You can simply pass the toolbar location and then set it to be none. You can do that if you want, or another thing you can do is if you want to see just specific toolbars. Let's say if I want to see only the reset toolbar, what I can do is pass the reset option in our figure. So here we have plot width, plot height, and then we can pass the tools attribute and then pass anything that you want to see. Let's say we want to see the reset and then the pan tools, just reset and pan. If you want to do that, you can pass that. So I'll copy that and then pass it to our other figures also. So paste it here and paste it here also. Okay. Now if I run this, I will only see pan and reset tools only. Okay. That's another thing you can do. So this is how you can link one or more figures by using linked panning. Okay, great. And in the next lecture, we'll continue our discussion on linking plots and we'll look at link brushing. Thank you, everyone.